So that was one application of the dot product. We could find out what the angle was between two vectors. Another thing which might be handy is that you can find the projection of one vector onto another. So we have the following theorem. The perpendicular projection of a vector A onto a non-zero vector B is given by this. So the P vector is the projection. We also denote it like this. So projection onto B of the vector A, and we can phrase this only in terms of a dot product and then this this length of B squared, and then I can see that I have missed vector B here. The correct formula is this one down here. So first of all, let's explore this a bit. So what do we mean by the perpendicular projection of a vector? You can look at this A vector. This is what we want to project. That it's a perpendicular projection means that we take the line that hits the B vector in a perpendicular angle. And then we say that the projection is this blue vector down here that goes from their common origin and then to this point. And of course, if they are not pointing in the same direction, or in other words, if the angle is larger than pi half, then we just extend B in the negative direction and then make this dotted line. And then the projection vector is this blue one, right? So how do we prove that P equals this number times this vector that I forgot up here? Sorry. So if you have an angle less than pi half or equal to, so if we have something like this, right? This is what goes on here. The angle between vector A and B is less than pi half. Then the length of P should be the length of A times cosine theta. That's just the trigonometric identity, right? This is just applying trigonometry. Clearly, if we make this drawing, then we should scale the length of A by cosine of theta to get the length of this line. So this means that in order to get the projection vector, we should get a vector with this length. But if we should have a vector with this length, all we need to know is in which direction we should have our vector. But clearly, if the angle is less than pi half, then the projection should point in the same direction as the vector B. So we just have to multiply by a unit vector that points in the direction of B. So that's just B over length of B, like this. So P equals this number times this unit vector, right? And then we just use the formula that tells us that if we take the dot product A times B, or A dot B, then we get cosine theta times length of A times length of B. So then we would get this number only multiplied by length of B. So we have to divide by a second copy of this vector B. And then we end up with this. So what happens if the angle is larger than pi half? If we are in this situation? Well, then the length of the projected vector should just be the same, only with a minus here, because we know cosine of theta in this case is negative. So we should have a unit vector pointing in the opposite direction of B times this length. So how do we get a vector pointing in the opposite direction as B, a unit vector? Well, it's just this one. And then we see that we multiply this number by this number, or this vector, and then the two minuses cancel. So in both cases, we see that cosine theta equals this. So A cosine theta equals this, and then all in all we get this. So now we can use the dot product for at least two purposes. One is to find the angle between the two vectors, and the other one is to find the projection of one vector onto another. We can also, as we saw earlier, we can also use it to find the square of the length of a vector. So in fact, what we have down here is also a dot product. It's just b dot b, right?